Hi guys, good evening. So welcome to Network Kings, and today's a demo session for SD-WAN, and the batch is gonna start from the coming Saturday. It's a weekend batch basically. Today we are here just for the introduction for the SD-WAN. Yeah, Amit sir, so over to you. You can start with the session.
Okay, thanks, Gaurav. So, hello again, everyone. My name is Amit, and I have been working into networks for more than 15 years with Tier 1 ISPs. Can someone please confirm? Am I audible? Maybe on chat. Okay. Okay, good. Thanks. Okay. So today we are going to talk about Cisco SD-WAN, or sometimes it's called as the Viptela SD-WAN. Both are the common names, I would say. The reason is Viptela was the first organization which invented, they worked on the SD-WAN core concepts. Later, Cisco overtook Viptela, the whole organization, their SD-WAN product. And then slowly and gradually, the Cisco migrated all the features onto their Cisco routers, onto Cisco platform. Earlier, specifically Viptela hardware was being delivered even via Cisco. So in slowly Cisco developed these integration with their Cisco routers. So now almost all features of Viptela SD-WAN, they are now available on the Cisco routers. So it's with the latest codes, of course, in the new iOS versions. So there are different models, different hardware, different softwares available for different features. Okay, we will catch up it later. So to start with, so this is the Cisco Live document that I usually follow. Just for introduction, it has nice bullet points to see what is SD-WAN, why we really need SD-WAN, and how it is better compared to the other vendors, because you all might be knowing there are different flavors of SD-WAN in the market, like Cisco Viptela SD-WAN. There are other vendors who are also delivering SD-WAN. For example, from Juniper, it's Versa, and HP, Dell, Nokia, Silver Peak. There are many vendors, Fortinet, Palo Alto. They have their own SD-WAN flavor, but the core concepts are same. We will go through those in this session as well. So core concepts are same about the SD-WAN. Okay, so let me quickly open my paint screen. Just a moment. So I hope my paint screen is visible, right?
Yes, it is visible.
Okay, thanks. So if you have any question, feel free to ask. If you have any kind of any question related to SD-WAN network, so whatever we are discussing. So if you have any question, you can interrupt me, or you can post on chat. Maybe I can answer. Okay. So
Are you presenting the screen?
yeah, this is what I was saying. So my paint screen. So you should see the Microsoft Paint, right?
Actually, I'm not able to see. Can you confirm with others?
Yes, I can say.
Yeah, it's visible.
Okay. Then maybe who? I'm sorry, I couldn't catch the name. Can someone come repeat? Who was not able to see?
Network issue, Keshav.
Okay, maybe you can try to rejoin. Yeah. Okay. So it would be. I will try to explain this about SD-WAN. What is SD-WAN? Why we need SD-WAN? What are the limitations that we have in traditional networking, which with SD-WAN we are trying to resolve all the traditional things, traditional complexities that we have with the legacy networking. Okay, so SD-WAN is software defined wide area network. Okay, I hope everyone is aware about this WAN, wide area network, which is the basically whatsoever WAN connectivity we have on the WAN routers. So I'm assuming all the friends that we have in this session. So everybody, you are aware about the basic networking, like what is router, what is routing, what is switch, what is routing table. Even if not, don't worry, you can interrupt me, you can ask me. I'll try to explain in detail. Okay, thanks. So SD-WAN is software defined wide area networking. It stems from SDN, which is software defined networking. So basically, with the legacy networking, like we have routers, right? We have WAN links connected towards the WAN cloud. So with the traditional networking, like this is, let's say provider, ISP, it is providing like MPLS or lease line. So whatever service it is there, so things are very much static and very much into hardware. So with SD-WAN, things are very much flexible. When, let's say, with legacy networking, let's say if we have multiple links on the routers, I'm assuming this to be, let's say, router 1, this to be router 2. So with traditional networking, these things are very much fixed. When I say fixed, let's say one of the link is having problem, it is having packet drops. So we cannot really dynamically steer the traffic which is coming from the LAN side. Earlier it was going through this link. We cannot really dynamically steer the link via other path, or we cannot dynamically say that whichever link is performing better, traffic should route over that link. So with traditional networking, in case one link is having packet drops, traffic would keep following that link. Option there to dynamically steer the traffic to the other best performing link. So this is one of the advantage that we have with SD-WAN, that we can dynamically steer the traffic across the best performing link. Even we can choose the application, that these are the specific applications, let's say Teams traffic, or let's say WebEx traffic, let's say YouTube traffic, browsing. So we can define that this is my critical traffic, it should go via best performing link, and this is non-critical, it can follow the bad performing link. Okay, so these are all the fixed things into the legacy networking. These are when we use the intelligent technology, which is SD-WAN. So it's basically based on the software defined networking. It is based on the software. So mainly we are using software coding in the background, which would measure the performance. Let's say for one of the use case, it would measure the performance of the one of the WAN link. In case that is not going well, there are packet drops, or let's say there is latency. So based on the software codings in the background, what we can do, we can write a policy to say that this traffic, in case there is a packet drop, X traffic should route via Y link. So SDN is software defined networking, from which SD-WAN is invented, software defined wide area networking. So SD-WAN, we are using concepts of SDN, software defined networking, into the WAN, specifically for WAN links on the WAN domain. Okay. Now there is one thing called as SD-LAN, software defined LAN, local area network. So that is towards the LAN, from WAN router towards the downstream network, towards the LAN network where switch is connected, or where users are hosted. Okay, so that is SD-LAN. That is called as software defined local area network, software defined wide area network, and local area network. So basically, what are the concepts of SDN? It says to separate different planes. Let's say control plane, data plane, management plane. So what SDN says, to separate these three different planes: control plane, data plane, and management plane. In very simple words, when we talk about control plane, what it means routing, or the routing protocols. For example, BGP. Okay. And when we talk about data plane, it means actual forwarding of the data. We will discuss about these things in detail, how control plane, data plane, and management plane are different. So it is actual forwarding of packets based on the routing information, which was learned via control plane. Okay. Management plane is management to the devices. For example, we do telnet to the devices, SSH to the devices, those sort of things. So the core concept of SDN is to separate these three planes. Earlier in legacy, you will see these three are integrated. These three are integrated in such a way that for control plane and data plane, everything is handled by one device. But in SDN or SD-WAN, these all planes are handled by different devices. So router is now relieved of the routing thing. We don't need to run any routing protocol on the router. So we are relieving router of the CPU overheads that we need in case we need to run the routing protocols. So in case of SD-WAN, we have one common device which will handle the routing for whole network. Let's say we have 50 devices, we have 100 devices. For all 50 or 100 devices, one common device will handle the all sort of routing. Okay. Any questions so far?
No.
Okay, good. Thanks for coming up. Okay. So these are the few, I would say, on the ground, I would say, because when we go through the Cisco PPT, we will see definitely different things, but those would be more into from the marketing perspective, right? From the professional services thing, like, sorry, my screen is visible, right? Can someone confirm, please? Do you see my screen?
Yes, yes,
Okay.
it is visible.
Okay, thanks. So the core advantages which Cisco proposes that with SD-WAN, one of the major advantages reduce cost. That cost would be less for the, of course, for the hardware, for managing the network, because as I said, the control plane now it would be handled by one common device. So CPU overhead is now lesser needed for the all network devices. So all the remote devices, they would simply be handling the forwarding of the data packets. They are not concerned about the routing. Routing is handled by one common box. We can have one device handling routing, or we can have cluster of devices, but they would be placed, they would be sort of, they would be named as the one device or two devices in cluster, or let's say three devices in the cluster. So so control plane or routing thing is not needed on the end host devices, let's say on the C routers. They would simply be forwarding the packets. Almost 70-80% of the CPU overhead is now gone. Okay, so it reduces cost because now we need less intensive processors on the remote devices. Okay, operate faster with better performance and security. So when I say better performance, because as I explained, with SD-WAN using software defined networking, we can say that always send our X application through the better performing line. So with legacy networking, we see our backup links are almost unutilized. With SD-WAN, we can define policies so that all the links are almost equally utilized, or at least all the links are utilized based on the applications. Okay. Security. With traditional networking, we need specific hardware, let's say firewall, Palo Alto, checkpoint, those sort of things, right? It is difficult to integrate legacy networking devices with the cloud security platform. Even in the legacy networking, we can host a firewall on the virtual machines, right? But here we have these inbuilt features into the Cisco SD-WAN platform. We have security features inbuilt into Cisco SD-WAN, like URL filtering, we have inbuilt into the SD-WAN itself. And even with Cisco SD-WAN, we have flexibility to integrate the cloud security. Okay. So next point is again coming on to same, the cloud and the networking technologies. So integrate latest cloud and the network technologies. So cloud, everybody must have heard of AWS, Amazon Cloud, or Google Cloud, or let's say Microsoft, Oracle. So we can integrate those cloud hosted devices into our SD-WAN network. So this is another advantage, that with Cisco SD-WAN, we can integrate the cloud. So we can host Cisco SD-WAN box on the virtual machine at the cloud, maybe on AWS cloud, on Google, or on the Microsoft. Okay, so we need not buy specific hardware to run the Cisco SD-WAN. We can simply buy a virtual machine from the cloud providers, and we can run SD-WAN on that machine. Okay, so why we need SD-WAN? Because of the traditional things which are the fixed with traditional networking. Let's say, very simple example I shared, that either of the link, let's say it's having packet loss or latency, it cannot dynamically shift traffic onto the other links, right? Okay, so which SD-WAN? So there are different vendors, so they have their own pros and cons, but Cisco is major provider for SD-WAN. Again, for this very simple reason, they have market outreach. They already have 60-70% customers. They are already using Cisco routers. So on iOS XE routers, so with just upgrading iOS, we can run the SD-WAN. So customers can reuse their existing hardware by just upgrading the iOS. Okay, this is one of the major advantage with Cisco SD-WAN. So we will discuss about the SD-WAN architecture and the components, SD-WAN fabric as well. Okay, so coming over to the advantages, one, we talked about the, let's say, the loss on one link. We can dynamically shift traffic onto the better performing link. Second is we have exclusive dashboard for whole network. You will see one beautifully designed page where you will see all details about your network. Let's say this is the homepage of the dashboard where centralized, this is the centralized dashboard. There you will see you have, let's say, total 50 devices in your network, out of which, let's say, 45 are up, 5 are down. Okay, sort of these things. So it will show you ready data. It will show you what are the top talkers. So they are already there. So what are the 10 users which are sending most of the traffic? What are the top applications which are being utilized? What is the CPU utilization, or what are the all devices which are having high CPU utilization or which is having high memory? Okay, so sort of those things. I mean, which are the devices which are having their WAN links in the critical status, where there are the maximum packet drops. Okay, sort of those things. So we have exclusive dashboard.
Sir, what is the meaning? What do you mean by this CPU utilization? It means utilization of that link.
So CPU utilization, when I say, it's the central processing unit, like your laptop also processes.
I just want to know that 50 devices are there. When 50 devices are there, they are using the single two links. And
Yes.
CPU utilization for two means 4 or 2 PCs are working, having CPU utilization high. That means they are using the link. They are using high utilization on that link or on that PC only.
So, or we can say like process utilization.
Yes.
That's a different, I think. It's a process utilization and link binding is different.
Yes. So let me clean it up a bit. So let's assume we have multiple edge devices. Let's say these are the remote routers. Okay. Let's say we have these remote routers, right? And we have a central place where this dashboard is there, or centralized device which is monitoring all the devices, right? So it will capture the CPU utilization, the processor utilization of all these devices. Okay. And it will display, let's say, top 5, which are having highest utilization, or whichever are on the critical stage. Let's say this device, it is having processor utilization of more than 80%. It will highlight on the home page of the dashboard that this device is having highest CPU utilization. You need to work now to improve the utilization there. You will see ready on the dashboard on centralized page that this device is having high CPU. You will now go to the device, log in and see what all things are happening. Does that answers your question?
Yes, sir. Yes, sir. Yes, sir.
Okay, good. So now when another thing you talked about the links, right? It will capture the link wise utilization as well. Or I would say per link utilization. Let's say on one device, we have 3 links. So it will capture the utilization across all 3 links. Okay. Even the utilization between 2 routers on each link. Let's say this device is using this link. This device is using this link to talk to each other. It will even capture the utilization across this path per link per device. So it will show you all sort of a beautifully designed dashboard, which will show how many total devices you have in your network, how many are up, how many down, for what all devices. WAN link is in critical status. Let's say it's flapping badly, or there are high packet loss. It will show you. It will show you highest utilizing users, that which users are top utilizing the network, what all applications are being accessed highest, processor. Okay. And there would be a separate window of kind of syslog, which will show that on what device what is happening, on which device which user is doing what. In case somebody is doing any change on, let's say I am logged into this device, I am making a change there. Okay. And now this change would be reflected into this dashboard, that some user is sitting there and making some change. Here you will see one drop down. There we can see on what device what all users are doing what configurations. Okay. So any questions so far? So this is called a single pane of glass, meaning at one single URL, by logging into, let's say, xyz.com, you will see this dashboard on the homepage, that what is happening in your network right now. What we can do with SD-WAN, we can go log into each of the device. Okay. Whatever devices are up, we can go log into those devices. If we want to make any change on those devices, we can do centrally, sitting on this place. Okay. So the point I'm trying to highlight here is that we can remotely perform the configuration on all the devices. We need not go log in to each device to make any change. We can simply sit on the centralized place. From there, we can make changes. This is the advantage of SD-WAN. We can centrally configure devices. Okay. We can do any sort of routing we want to do. We can do from centralized plane. Even if we want to, let's say, push similar configuration on multiple devices, that also we can do. Okay. So let's say we have devices, we have newly procured 4 devices, and we want to push similar configuration on all the devices. We can do that sitting on the centralized plane. We need not go log into each and every device. We will simply push the configuration from the remote. The similar configuration would be pushed onto all 4 devices. Okay. I'm expecting question at this point of time.
Sir, my one question is there, Ramesh sir.
Mhm. Tell me.
Suppose that our this centralized device we manage which is going to down. In this case, what the scenario will be impact all the like other devices, 50 devices, correct?
So you are saying we manage this down, right?
Yeah.
Okay. So what is the question now? I'm assuming the we manage down. So,
Yes.
so what is your question? I mean, you are asking, so what would happen in case we manage or the central device goes down? Is this
Yeah,
your
central
question?
device going down,
I
then
think
what the
it-
situation?
yes.
Okay. Okay. Good question. So there would be no impact because this is vManage is part of management plane. It is doing all sort of management things. Nothing for control plane, nothing for data plane. Data plane is handled by remote devices. They are up. Control plane is handled by separate device. vManage is just a management plane. So I'm giving a very simple example. There is one router. You are not able to telnet to the router. What is the impact? Your traffic is running, but you cannot telnet or SSH. There is no impact, right? It's just that you cannot log in, but your traffic is running, no impact to the end device. Just from the server where you are doing the telnet, that server is not available. So there is no impact, right? There is, you can say it's a lowest priority, lowest criticality impact that you are not able to log into the device, but traffic is running. Customer says everything is good. I don't see any problem. So this
So
is
okay.
similar scenario.
So,
Mhm.
so sir, I'm getting question now. So now my concern is, as you said, like there's no impact of control plan and data plan. That means my all the routing protocol or the source and destination will be reachable, except the VMN is down, and the
Right.
dashboard will be not display, and we cannot view the other remote location about their utilization, process utilization, link utilization, whatever may be the services running in that remote location. That's true.
Absolutely. Absolutely. So
Okay, so
just
okay.
for go ahead. Sorry.
No, no, it's okay. I got it.
Okay, thanks. So just for your information, in case if not aware, so this central device, it is called as vManage. Okay, this is a device you will not see anywhere physical vManage. vManage is always virtual. Okay, it's you will see a VM on which you will install the image for the vManage. That's it. So this is a reason where there is very low probability that vManage going down. In my entire, I would say career, I've been working into SD-WANs for more than 5 years. I haven't seen a single case where vManage went down. Again, the same simple reason, because it's hosted on the virtual machine, okay, and it's not consuming much of the resources like in terms of CPU or memory. It needs very less CPU or memory, so it's very stable device. Okay, so
This is
this
like cloud based.
yes, so cloud based or on premise, both options are available. We can host it on cloud or we can host it on premise. I mean, if we can buy our own server, we can host vManage on that server as well. We will see. Mhm.
Sir, do we manage this thing if we want to manage on network? So we have to come on network, or we can manage it remotely. Means virtually. We can we manage it virtually?
Yes. So it depends how you want to do the connectivity, because vManage, when we are saying we are hosting, we are having a vManage image, iOS for vManage, we are uploading that iOS on virtual machine, let's say on VMware, or using VMware or something. So there would be different interfaces on that device, similar to router. Let's say there are 3 interfaces. Then you can have 3 ways to connect to the device, to vManage. One of them you can use for, let's say, using port 443, 8443. I mean, based on URL. Other port you can use for the CLI login. So there are different interfaces. It's up to us how we want to utilize each of the interface, either for CLI login or for the GUI login. So it's up to us.
Okay, sir.
Okay. Okay. So this vManage is part of the management plane. What is management plane? Management plane is one of the part of the SDN. We talked about control plane, we talked about data plane, we talked about management plane, right? So management plane is vManage. Okay. So management plane is vManage. Data plane is the remote devices like C routers. They are part of data planes. The job of the router would be simply to send the traffic to the other devices. There is no routing protocol running for the WAN side. You won't see BGP running towards the WAN on any of the edge device. That routing is handled by proprietary protocol, which is from SD-WAN, from Cisco, but there is a separate device which would be running control plane sort of things for all the devices. That device will handle the control plane and it will share the best path, best routing information, whichever it needs to be sent into the forwarding table. So that would be sent over to the remote devices. Meaning this device need not talk to other devices for routing. It just needs to talk to one central device, which is handling control plane for all SD-WAN devices. Okay. SDN, software defined networking, three things: control plane, data plane, management plane. For management plane, we have vManage, which is called as single pane of glass. It does everything from vManage we can do, like monitoring the devices, configuration on the remote devices. Even we can push the iOS on all the remote devices via vManage. Okay. We can SSH to remote devices from vManage, CLI login. Okay. We can run different commands on the remote devices. Like, let's say if you want to run command show IP route on edge on remote device, you can run this command sitting on vManage. Okay. You can see utilization of each interface, each WAN link for remote devices sitting on vManage. So vManage is centralized management platform. From there, we can do almost everything for the network. Okay. Now, do you have a bit overview about vManage, how it would look like? What does it do?
No, sir.
Sir,
Sorry?
I have seen some when means I am working for the HDFC project right now. So I have a little bit knowledge of this thing, SD-WAN. We are just implementing iOS on router, and there is one service that is PSPN service. We have to stop that service, and after that PNP service. Yes.
Yeah. Plug and play.
Plug and play.
Yes.
And one command is there. So I'm not.
Yeah, controller mode enable or the request platform software. There are several commands. Yes, I understand which command you are talking about. Yes, we need to stop this PNP service. Yes.
Yes, we have to stop that PNP service and upload the iOS, and
yes,
we got the image of that configuration from the central team, and we just implement that configuration. Just we have to copy, and it will take if it come on link, means if the link come up, then it will take it. What do I say? The configuration will come up by itself. Means it will take it from the central device.
Yes. So let me tell you that what that feature is about. So let's say if we talk about the traditional networking, how it happens. Let's say you are deploying your one site. Okay. So what would be the first step, right? So let's say you are going to configure. You need, let's say, one router. So what you will do? You will buy one router, right? You will purchase you will lease this one line to provider, right? be it internet or be it MPLS line. Now, what will happen? Let's say you are sitting in headquarters. You need to, deploy one branch. So what you will do? You will deliver. You will ask Cisco or vendor to deliver the router onto the site. Now, let's say, assuming the router is also delivered, WAN line is also delivered on the site. Now, what would be the next step? To send engineer onto the site to take console of this router and do the initial configuration, right?
Right.
So after doing the initial configuration, what you do, you take the access normally, you take the access of the device remotely, and then you perform whatever final configuration that you need to do, right? This is the
Right.
usual step.
Mm.
So now with SD-WAN, what happens? Let's say hardware is delivered onto the site. You have link connected onto the device. You need not do anything on this device now. So normally on most of the sites, you will see, let's say for small offices, there is no technical person on site. There are non-technical people. There is a written manual that you have received now device. Just connect cable on, let's say one port, gigabit 0/1. Just connect internet line on the device. As soon that internet line is connected onto the device, that cable is connected, port came up, it will automatically integrate with the existing network as part of SD-WAN. This is the one of the advantage that we have, or the PNP that you were talking about. It is this thing that using plug and play, what it means, plug and play. You simply connect the WAN cable onto the router. Your device will go online in 2 or 3 minutes. It will fetch all the configuration from the server which is hosted on the central site or the centralized platform. All the configurations would be stored on vManage, let's say, the centralized platform. Based on the device serial number, we just need to whitelist or relate the serial number of the device which we will have, which Cisco has delivered to us, let's say. Then what we will do, we will we will integrate or point the serial number with the corresponding configuration. Okay. So now, as soon this device is connected to the internet line with the features that SD-WAN has, it will automatically fetch its configuration from vManage and it will go live. It will start communicating to the other sites, whichever are already live. So we don't need now to send field engineer onto the site to take console, to do the configurations, to give the access to the remote engineer to perform the full configurations. So you see, the efforts and time is eliminated now. As soon you connect the internet line, your device is live. This is called as PNP, plug and play for Cisco routers, where the hardware is Cisco router. Okay. And it is called as ZTP, zero touch provisioning for Viptela hardware. Now, initially, when Cisco purchased Viptela SD-WAN as an organization, then these SD-WAN features, they were not available on the Cisco routers. They were only available on the Viptela proprietary hardware. Viptela was a company, they also developed their own routers similar to Cisco. It has a bit different command syntax. I would say 70% it's same as Cisco CLI. 30% there are some customized commands which are proprietary to Viptela platform. So Cisco and Viptela. So ZTP is zero touch out of configuration or day one configuration. We simply need to connect the WAN line. It will automatically go and fetch the configuration from the server. So there would be system defined configuration on this device as part of the staging configuration from the vendor itself. Cisco themselves, they will configure this device with the server IP address of each customer, depending which customer is purchasing device. So there is one-to-one mapping of the server where configuration would be saved. That server IP address would be configured as part of factory default configuration on this device. So this is called as ZTP for Viptela hardware, PNP plug and play for Cisco routers. Okay. Now these Viptela devices, they are called as V edges. Okay. Cisco routers, they are called as C edges. They both are they both would be placed at the remote site and end device. They are equivalent to C routers. So these are V edges or C edges. Their functionality is same. Okay. So this is the another advantage with SD-WAN, that we need not send engineer onto the site, do the initial configuration. Okay. Other advantages, we can remotely push, upgrade the iOS. We can remotely configure and monitor. Okay. Now let's quickly move on to the SD-WAN components. In very brief, I will share with you.
One more, I just got one question.
Mhm.
As you said, when we are going to upgrade the iOS, so before doing upgrade, do we need to check the existing, like your memory capacity, something, or that will support default if you used to upgrade the iOS?
So yes, so definitely. So when we are going to push the image onto the device, so it will
Mhm.
first check by itself how much memory is available, if sufficient memory is available or no. It will do it as part of pre-check. If in case memory is not available, it will it will drop the processing. It will stop
And
processing the. Mhm,
as you know, no, like in our India, many finance companies and big organization, they're
mhm.
still using old series of Cisco iOS routers,
Yes, yes.
So if in that case, if I recommend to customer, if we are going to use the existing, but existing memory capacity is not enough. So again, we need to upgrade the memory and then we can go with the next step, right? That would be the approach to upgrade the new iOS, sorry, image of this SD-WAN, right?
So I would say there is neutral answer to your question.
Mm-hmm.
You have very
Mm-hmm.
valid question, and it happens for most of the customers, right? The reason is, when I say neutral answer, why I say, because Cisco is providing SD-WAN only on the latest routers. On the
Okay.
ISR G1, SD-WAN is not feasible.
Okay. So suppose that means if I am providing new solution to my customer,
Mhm.
that means again the cost is going to add for the upgrading the new ISR router also, right?
So
In that
yeah,
case, how should I manage?
that is correct. So let's say if you say your customer is using, let's say, ISR G1 router, right? Let's say
Mm-hmm.
3900 router, or let's say 2900. So any of the legacy, but when I say those routers, those are already end of sale, end of support. Those are end of life routers, right?
I get it. Agree.
Those routers don't have any support available from Cisco. So SD-WAN is not available for those hardware.
Okay. Okay.
Okay.
Sounds good. Okay. Thanks.
Okay. Thanks. So I hope my screen is visible, right?
Yeah. Yeah. Mhm.
Okay, good. So so it's showing the comparison with above dotted line. You will see the traditional networking that we could only use, let's say, MPLS to go to data center. At data center we will have internet connection, right? So meaning, what it is trying to show here is we can mix and match the WAN links. If you see at bottom, these are the user device things, let's say PC, mobile, APs, what WLCs, servers. This is the first circle. Then this is the branch site. This branch, it can use MPLS as well as internet line both to go to the data center or to go to internet. So we can mix the WAN lines. We can use different transports, different WAN links for to go to remote site. In traditional networking, you cannot use internet line to talk to the another site which only has MPLS line, right? So we can mix different WAN links. Let's say one site may have MPLS and internet line, other site may have only either MPLS or either internet. Then also similarly that we do in traditional networking, like we use MPLS for the critical traffic, let's say for voice traffic, and we use internet for, let's say, lower priority browsing traffic, right, or file sharing. So this is the another advantage that we have with SD-WAN, that we can mix different WAN links, different type of WAN links, let's say MPLS, internet, 4G, LTE, we can even use those WAN links as well for SD-WAN. Okay. So these are the few disadvantages with traditional architectures, like those are expensive, hardware centric, fixed capacity, difficult to support, that in case we need to roll out 50 devices, we need to go log into each of the 50 devices to do the configuration. But with SD-WAN, simply sitting on the centralized platform, we can configure 50 devices remotely. Okay. So poorly integrated, connectivity centric, these are all marketing sort of things. Inflexible, because we have control plane, data plane on each of the router. In traditional networking, each router runs its own routing protocol with, let's say, provider or between sites. But with SD-WAN, only one device is running control plane, one device is running routing protocol with the edge devices, but no direct control plane, no direct routing between each of the edge devices. So edge devices are simply handling the forwarding of the packets. Okay. So now, as part of the Cisco SD-WAN, there are two flavors, Cisco Meraki and Viptela. Okay. Cisco Meraki, it is for the small organizations, small and medium enterprises, let's say life insurance companies, NBFCs, let's say PNB Housing Finance or Reliance Capital. So sort of those organizations, Cisco Meraki is feasible because they have less users on their remote sites or on their sites, and they don't need much of the features, let's say QoS, right? It's not expected QoS to configure on the smaller sites. So Cisco Meraki is for those sites, those SME, small and medium enterprises, where there are less users. They don't need much complex functionalities like different routing protocols or different WAN links. In case, let's say, on any of the site, they want to use only one WAN link with smaller end device with lesser cost, they can use Cisco Meraki, and say almost similar functions we have as we have in Viptela. We have similar functions with Meraki. So concept is same, the SD-WAN. The control plane is separate, data plane and management. All these planes are separated. Okay. Similar things we can do with Meraki, like we have dashboard, we can see what is happening in our network. We can remotely push the configuration. We can remotely run the commands. So with Cisco Meraki, we don't have CLI login to the devices. With Viptela, we have CLI access to the devices. We can go log into the device and run the commands. But with Cisco Meraki, CLI login is not available at all. Okay. So now coming on to this SD-WAN architecture, we have orchestration plane, management plane, control plane, and data plane. So orchestration plane, what does it mean, orchestration? So orchestration meaning arranging the things, telling each person that what you need to do. Okay, let's say event organization. We have event organization companies, right? That is very simple example of the orchestration. They orchestrate what task should be done by who and how, right? So orchestration is, it is sort of coordinator. It is instructing each and every device that this is your job, you do this, this is your job, you do this. Okay. So it's sort of orchestration plane, it orchestrates the connectivity. So the on orchestration plane, there is device called as vBond. So V, small v, it signifies Viptela, that it is invented by Viptela, vBond, vManage, vSmart. So wherever you see small v, it was invented by Viptela. Okay. So orchestration plane or vBond. So any device, let's say we have a SD-WAN network where we already have 50 sites running. Now we want to onboard another site or another router. That device cannot be integrated to the other site. That device cannot talk to other 50 sites until and unless it authenticates to vBond. So vBond is first point of authentication. As soon we plug a new device in our network, very first point of contact for new device would be vBond. It will go to vBond. Now it's job of the vBond to share the details about the other network. A device cannot go directly to vManage, vSmart. vSmart is part of control plane. So end device, which is a new device, it will not know about any other device except vBond, either by factory default config or by manual configuration. So when we do the manual configuration on the edge device, the very first thing that we need to do is to define vBond IP address. And we need, of course, routing to that vBond IP address. So vBond is again a virtual machine. It is hosted on VM, just like as vManage. There is no physical box on this. Although on vEdges also we can install the image of vBond, but mostly you will see vBond as the virtual machine on which vBond image is installed. Okay, so now an edge device which is going to onboard to the network, very first point of contact would be vBond. By manually specifying the IP address of vBond, it will create a secure tunnel to vBond. That I am new into this SD-WAN network and I want to join rest of the network. Okay. Any question so far?
No.
Okay, good. So are you guys with me? Are you getting the things that I'm explaining? Any questions so far? Or, I mean, are you okay with the speed that we are going? Too fast, too slow?
I have one question, sir.
Mm-hmm.
Actually, I'm not from networking background,
Mm-hmm.
and I'm from instrumentation and automation background.
Okay.
So, what are the industrial application examples for where these SD-WANs are getting implemented? Like
Okay.
so like plants or any industry examples for what purpose?
Yes. Yes. So just a moment. So for the organizations that I have seen example, I have seen organization working zone. So largest customer I worked for SD-WAN, Siemens. My screen is visible, right?
Yes, sir.
So Siemens is the largest client which I worked for SD-WAN. They have almost more than 1,000 sites across the globe where they are running SD-WAN. Okay.
Okay, that means industrial sites.
Yes, 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 absolutely. Schneider,
Yeah.
Johnson & Johnson, Otis, these are all instrumentation, I would say into instrumentation domain mainly, right? Then other customers, let's say Sony, right? There are a lot of customers. They are almost all customers. They are using now the SD-WANs, be
So-
it from any industry, be
Yeah.
it software, Infosys, TCS, any organization you talk of, HCL, organization themselves, for them also they are using this thing.
Okay.
So only Cisco will be providing this SD-WAN or other vendor?
Yes, so there are other vendors like major provider is Cisco SD-WAN. Then we have Versa, which is from Juniper. Okay. Then we have Silver Peak. This is a different company. Then we have Dell, which is Velo Cloud, SD-WAN. So these are all different flavors of the SD-WAN. Let's say Fortinet is also providing the SD-WAN. Then there is Palo Alto. Then there goes Nokia, Nuaz. There are many vendors now. They are having their own SD-WAN. But the concept is same, that control plane, data plane, and the management plane. So these are, this is the baseline.
My company is using Kato Firewall. So I don't.
Sorry, you were breaking up. So you were breaking up. Could you repeat it, please?
Actually, in my company, we are using the Kato SD-WAN solution.
Could you spell it for me?
CATO.
Okay.
So this is
Okay.
the actually I don't know that the first time I have listened the current organization, because current organization is MNC. So this is UK and US based standard they are using. So this is I'm not much familiar. That's why I'm asking questions.
Okay, but you will see the core concept is same. Wherever you will see SD-WAN, the concept is same. Okay.
So is that Palo Alto doing the same thing?
Yes. So as much features you have with Cisco SD-WAN, you might not see those all sort of those features into the Palo Alto, but yes, they do have something. If let's say Cisco SD-WAN has 50 features, Palo Alto may have 10, 15, 20 as of now. So this may be the difference level as of now. Again, for same reason, because Cisco has already their devices installed at most of the customer locations, right? So let's say one organization, they have their 50 sites where they already have the Cisco routers, right? Now that organization might not have 50 Polos, right? They might have only 5 or 10 Palo Altos. So this is the reason. Instead of going for 50 more sites for a customer, instead of buying 40 Palo Altos, they would try to rather use Cisco routers, right? To save the cost.
I think Kato is a checkpoint SD-WAN solution. This is the reason, because in most of, if I'll say in UK or in European country, they are using, yes, correct, because the particular organizations belong from that particular location, I can say.
Yes, maybe.
Yes, correct.
Thanks. So I would say again, the concepts are same. They are using same concept of SDN, that separation of different plane, orchestration plane, and sort of those things, right?
Yeah, you're right. Because actually, if I'll talk about the ranking wise, of course, Cisco is leading this particular technology.
Yes.
And there are other vendors also who is coming to this in SD-WAN, but yes, Cisco is number one. What I read or what I understand from the different companies and all.
Yes, that's correct. Okay, so I have just few more things. I'll take 2-3 more minutes, then maybe we will try to wrap up in case no more questions. Okay, so let me share my screen. So you see different devices like vBond is handling the orchestration plane. It orchestrates the connectivity across the devices. Any device which is new into the network, we are installing a new device at a new site, let's say, it will first go to vBond. Until it is authenticated to vBond, it will not be able to join the SD-WAN network. And Cisco SD-WAN network, it is called as ZTNA, Zero Trust Network. Meaning each of the device in the network, they don't trust each other by default. They won't connect to each other until they are authenticated using certificates. Certificates signed by the certification authority, CA. So all the devices, they must be certificated. They must be authenticated using SSL certificates. Until those certificates are authenticated, these devices cannot talk to each other. They cannot form secure tunnels between each other. So it's called as zero trust network. These devices, they have zero trust on each other until the certificates are exchanged to authenticate each other. Even if these vBond, vManage, vSmart, even if these controller, these are called as controller, even if these controller devices, they would also be authenticated at day zero, I would say. At the time when these devices are getting installed, when we are putting in the image, even they won't be able to connect to each other until they are authenticated using certificates. Okay. So this is another advantage, that it is very much secure. We have this SSL based tunnels across all the devices, between the controller devices, between vBond, vManage and vSmart themselves. They are called as controllers, and even between the controllers and the edge devices. So all communication is secured based on the SSL or TLS tunnels. Okay. This is the icon for vManage. This is the icon for vSmart. This is the WAN edge. So vSmart is the control plane. It handles the routing. Okay. vBond orchestration plane, vManage management plane, vSmart control plane, WAN edge. It can be Viptela edge device. It can be Cisco ISR, Cisco ASR, ENCS, or white box. Okay. We will discuss about white box and ENCS later. Okay. So we can use different WAN links. We can mix different WAN links like 4G, internet, and MPLS to connect edge devices to the controllers, to the centralized control network. And with vManage, we can communicate using APIs as well. We can fetch the details which vManage has captured about rest of the network. We can fetch those details via APIs, application programming interface. We can fetch the data on the GUI platform, on the GUI level itself. We need not go to CLI and see the utilization. There are certain defined API queries. APIs are like, let's say if we are logging to Facebook, we want to capture the messages of our own account. We can run a query on the GUI platform itself, on graphical user interface, and we can capture sort of the data. Okay. So I think this is all for today. Any question, anyone?
One question is there. So this is like device-based licensing, or this is according to traffic, HA, how many like bandwidth
So
we are using?
feature-based licensing, like with default licensing, you don't have security enabled. When I say security, like URL filtering, DNS security, advanced level of security, whichever you have with next generation firewalls, that security things are not available with the default featured license. Then we need to go to the advanced license for those features. So it's not similar to the Cisco routers or the legacy where we have licenses for throughput. It's not that, like here we have feature based licensing. Okay.
Okay.
Sir, I have one question.
Mhm.
If one router gone faulty, then if we connect one WAN link on that router, does it take it will it take the configuration by itself, or we have to manage it, or we have to supposed to send our engineer over there to give that again same process is there?
Okay, I understand. You are saying we have one device which is live that has gone
Yes.
faulty. Now, what would be the next step, right? So, of course,
Yes.
it would be to send engineer onto the site.
Okay.
But we will see exclusive logs. I would say in-depth logs about what happened during last moments. We will have that.
Okay.
Okay. Even if anything such happens, it automatically captures the crash logs.
So how do we know that? Will it show on that this vManage?
So it will be stored onto the edge device itself. It's similar to the black box that we have on flights, right?
Okay. Okay.
Yes. So it would be stored onto the edge device itself.
Means whatever happened in that router, whatever.
Yes.
Okay. Okay.
Yes.
Okay, sir.
So these all the running in application layer, all those, this correct?
When you say all those, you mean any device or?
Yeah, our this WAN edge device to our B manage. between all the like traffic going through application layer.
So WAN edge device. So when you say Cisco router, right?
Yeah.
When you talk about Cisco router, which layer you say at which layer that device is working on?
Cisco router, it's network layers.
Yes, same. Same is the case for the edge device. It is also working on layer 3, but we are connecting layer 1. We can connect